What exactly is time? And why is it relative? Civilizations before us tracked it as the rising and setting of the sun. This led to sundials, calendars, and clocks to measure more precise time. But, Einstein came along and made everything a bit more complicated. He came up with the theory of relativity to explain how mass, time, and space all interact with each other. Einstein's theory of relativity tells us that time always passes, but travels at different rates for people in different situations. Einstein calls this time dilation, which is the difference of past time between two events, where the observers are not moving the same way. This may sound crazy, but time actually passes slower the more you're moving. Let's demonstrate this. Imagine your friend is driving a car moving 30 miles per hour, and you are standing on the side of the road. If your friend throws a baseball out the window at 20 miles per hour, you would see the baseball moving at 50 miles per hour, because the baseball's speed is added to the 30 miles per hour the car was already traveling. However, from your friend's point of view, they see the baseball as moving at 20 miles per hour, because they were already moving at 30 miles per hour. The two perspectives of you and your friend are called inertial reference frames. Different inertial reference frames happen when two different viewpoints move at different speeds. In this case, your friend is moving at 30 miles per hour, and you are standing still. From your reference frame, the car is moving by at 30 miles per hour, but from your friend's point of view, you and the world around them are simply moving backward at 30 miles per hour while themselves and the car are sitting still. Neither one is correct or incorrect because it all depends on what point of view you're looking at it from. So this leads us to a big question. What does the theory of special relativity tell us about time? Well, from two different reference frames, or points of view, you and your friend saw the same event take different amounts of time to occur, simply because you were moving at two different speeds. Therefore, time is only relative to your point of view. This means, how quickly time passes depends on how quickly you're moving through space. In this case, from your view, time is moving faster for you than for your friend. And from your friend's point of view, time is moving slower for them when compared to you. Einstein applies this principle of time dilation to the cosmos, such as traveling close to the speed of light. The speed of light is 300,000 kilometers per second. And this value is the same for all viewers. To demonstrate time dilation with the speed of light, let's look at light beams between two sets of mirrors. Both groups have a beam of light bouncing between the two mirrors. However, the first set is moving close to the speed of light. Now, the same amount of time has to pass between when the beam hits the top and bottom mirror. But how does the same amount of time pass if the light beam between the first two mirrors is clearly traveling a farther distance? Well, the only way for this to be possible is if time for the first set of mirrors is moving slower than the second set. This is because speed equals distance divided by time, and the two beams are traveling at the same speed. Therefore, since the first beam travels a larger distance, the value of its time must also increase in order for its speeds to remain equal. Time slows down for the first set of mirrors, allowing the light to travel a larger distance. This would mean, if we let the demonstration run for 1 minute, the beam would continue to hit the top and bottom mirrors at the same time. Because 1 minute for the first set is longer than 1 minute for the second set. Let's recap what we have learned about time. Time is not a set unit, which means it is relative to your reference frame. Einstein's theory of relativity taught us that time always passes, but does not always travel at the same speed for people in different situations. As we saw in the example of your friend throwing a baseball out a car window. Finally, the mirror example showed us how time dilation is applied to objects moving close to the speed of light, and that time passes slower the faster you are moving. Thanks for watching. We hope you enjoyed and learned something about the relativity of time.